Hello, I'm Ekin. Today I will present my machine learning based 5G signal quality classification project. The main purpose of this project is to use 4G and 5G RAN monitoring data collected by the ElasticMan 5G monitoring framework running on FlexRAN and build a system that can classify the signal quality into three categories: poor, fair, and good. This project is not only about training a model, it covers the entire pipeline, including data understanding and preparation, training multiple machine learning models, comparing them and selecting best one, implementing CRUD operations like get, post, put, and delete, and finally creating a dashboard interface to interact with the system. So overall, this project helped me gain experience in machine learning, backend development, and basic front-end integration. Let's start with dataset explanation. The dataset used in this project comes from the ElasticMan 5G monitoring system, and I was provided with 6 preprocessed SCV files. These files include moving away, moving closer, stable long distance, stable mid distance, stable short distance, and stable short distance too. These datasets were already cleaned and preprocessed by the research team, meaning that missing values, noise, and draw signals inconsistency issues were eliminated before I received them. So in this project, I did not work directly with the raw RAN logs. My task was to combine all the 6 datasets, extract useful numeric features, assign quality labels, and prepare the data for machine learning. This dataset includes different mobility patterns and distance scenarios, which makes the classification task more realistic and more representative for real-world 5G behavior. Let's talk about training ML models Python file. This is the most important part of my project. So, start with a lots of library, and then this is our first function, load and prepare data. This function loads all the SCV files, merges them into one data frame, extracts numerical features, assigns the labels, scales the feature using standard scaler, here, encodes the labels using label encoder, and this is the label encoder, splits the data into training and testing sets. This function is crucial because the scalar encoder and future ordering that it creates must later be used in the API for correct predictions. And let's talk about train and select best model. This is the main function. It defines a list of ML models including random forest, gradient boosting, KNN decision tree, and trains each of them using train single model, records their performance matrices, pilots comparison charts for accuracy and F1 score, selects the model with the highest F1 score, and then returns the best performing model. In my results, Random Forest achieved the best performance, so it was selected as the final model. This is the summary of training results. You can see results of all models, and most of them have accuracy 1 because my dataset is already cleaning. And let's talk about API Python files. After finishing the machine learning pipeline, I built a Fast API backend to turn the model into a real application. The API has four major sections. First, loading the saved machine learning components. When the API starts, it loads the best model, scalar, label encoder, and feature texts. This is features that I used for my model trainings. This ensures the API uses the exact same transformations as the training environments. And then I have health endpoint. This is a simple endpoint that returns the system status. It is used by the dashboard to check if the backend is running. And I have predict endpoint. This is receives feature values from the dashboard. This is the most important part, I think, and arrange them in the correct order, apply scaling, feeds them into the trained model. And I have CRUD endpoints, of course. Get, post, put, and delete. Let's open our documentaries. Okay, I have a get. Get records means retrieves all stored records, and post adds a new record, put updates an existing record, and delete removes the records. So when I run the system, then I have a dashboard in my HTML file. So let's get to dashboard. This is my dashboard for 5G signal quality monitoring. And we have a inputs here. Then when we need to check health, it means status healthy, model load, yes, metrics available. When we get to the Swagger EU with only one button, just click here and it's back to this. Then we have CRUD operations here. To conclude, this project demonstrates the full workflow of developing a machine learning application using real 5G monitoring data, training and comparing several ML models, selecting the best model, deploying it as an API using Fast API, adding CRUD functionality, and designing an interactive dashboard. So I have an example. For example, I need records. Get records, and we have a JSON format records. Let's click on trade out and execute. And it's come from all records. This is the example. So this is my project. This helped me understand how machine learning models are integrated into real systems and how end-to-end ML applications are developed. Thanks for listening.